All right, so let me just give you the kind of the big picture of how the lab's going to work. I've made a doc file, a docx, I guess, file called lab1, something like that. It's in an assignment in course content. So first of all, you want to open up Blackboard. As a general point of order, let's try to use Google Chrome, just to all be on the same web browser so we don't have browser issues. I know it works on Chrome, so let's stick with Chrome. So if you get into Blackboard and go into course content, and then in course content, there's a folder I just added, lab statements and materials. Go in there. And in here I have lab 1, right? So once we're done with everything, you'll submit your answer to this when we're done with everything, all right? And that's how you'll get points. But this is the actual lab. What you want to do is to save a copy of that on the computer you're working on, or however you save files, all right? That's kind of up to you, but you want to have a local copy of that. So I'll save as, I'll put it on the desktop because I'm lazy. If I could find the desktop. Well, come on, desktop. So, and I'll just maybe tack my name onto it so I know it's mine. Cook. There we go. Of course, once I get into the file, so you want to have Microsoft Word open, right? Although I think it'll automatically open once you click on the file, right? Am I right? I'm right. So the format of how we're doing things is I give you this docx file, and there's a list of questions. We're going to go solve the questions one at a time, and we'll put the answers into this file. I think we should make a convention. Let's put our answer text in blue so I can see where your answer is versus where the problem is. Do you guys know how to change text to blue? So for problem number 1, there's really not much. Oh, stink. This stupid automatic tabbing, it drives me nuts. So undo automatic numbering. If it tries to start automatic numbering, you just hit undo automatic numbering so we don't get all this indentation that's useless. Anyway, so I'm going to try to, okay, I started Desmos and made my account. Hooray. All right, so, and then I want to make that, since that's like an answer, I'm going to make that text, see if I can figure it out. Blue, pick whatever blue you like, just the blue we can see. What do you guys want me to use? I'll tell you what, I'm going to use the darker one because I'm going to use purple, actually. I think purple's easy to see on these silly projectors. So now, I say, okay, I started Desmos and made my account. So you need to, if you guys haven't already, let's go to the Desmos website and make an account. Now, I can't really do that because I've already done it, www.desmos.com. Yeah, see, it actually remembers me from the last time I was here. But you guys might be new to it, so you'll have to, you can create an account. If you've got a Gmail account or whatever, but make sure you remember your username and password for Desmos, so because you'll want to come back to it later, future labs. So I'm going to give you guys.
Do we have like a classroom, or we just go to the graphic calculator?
You can just go into the graphing calculator, like this right here. Oh, yeah, just hit. Oh, no, not yet, not yet. A little bit later, I have something I'll share with you. But at the moment, you can just open up the graphing calculator. I mean, at the moment, I'm just asking you to make sure everybody can get into Desmos and you have a username. Once you have a username, then you can, save your work, come back to it later, stuff like that, You can also share your work with others, through the sharing. There's options to share work in Desmos, which is super nice if you're working together with classmates on a project, something like that. What's that? Well, once you've done something, it's it's not apparent yet because you haven't. I don't know what kind of view you're in. Yeah, share graph. Okay, so is everybody done through bullet point 1? We've all got Desmos working? Great. Okay, so next part. Graph the following functions with Desmos. And then I say for each function, paste a picture of your graphs as the answer to this question. So that's pretty simple. We just go up. You can, right there, we just put, like, for example, I think you could do cosh x if you wanted to. Probably would just graph it. But as a point of order, I try to put y equals cosh x just to, you don't have to put y equal to, but you could just put cosh x. I mean, it's up to you. That's one of the nice things about the Desmos app is that it's pretty forgiving. There's like a little bit of, there's not just one way to do something. It's somewhat smart about how it interprets your input. Okay, so there's cosh x. Now, how are we going to take a picture of this and save it? How are we going to take a picture of this in such a way that we can get it to that doc file? What do you guys think? The heavy-handed approach would just to do a screen capture and cut and paste and crop, right? But there's a better way here. Desmos actually has a way. So if you go up and trying to remember where it is. If you hit that share button we talked about up there, you can see export image. So if I export image, and you can play around with different settings. I'm just going to go with the default for now. Download PNG. Is that okay? So I download PNG, I open, and great. Now, let's see here. I copy it. Go back over here. Control V. Goodness gracious, I think that's a little bit bigger than I want. So maybe make that a little bit smaller, right? How big do you think we should make this thing? Right. I mean, make it as big as you want, but make it a little bit smaller. Yeah, I mean. How do I get off the what? Down, hit the, oh, perfect. So that's good. Did you copy it?
Yeah, I did everything you did and you brought me to the screen.
Brought you to that screen. Now we got to go to the Microsoft Word. And then like click under cosh. Yeah, now like Control V or, yeah.
Control what?
Control V. So you at the moment have that. Huh. All right, so you've got the cosh X in there. Can I play for a second? So we go download this PNG. And this, just hit like open. Or you could show in folder. I think open's good. So you got paint selected, which is good, fine. Select, maybe select all is what we need to do. Copy. something like that. Now, if I was making a report or something, I might crop this picture. Do you know how to crop the picture if you want? Well, so here's different strategies. So suppose I don't like that picture and I want to crop it. How would you crop it? I think there are format picture options inside Microsoft Word. Yeah, some of you will open up in Paint. Mine's opening up in something else that I don't like. Well, Paint's fine. If in Paint, what you need to do is select all and then hit copy, was what we just found out back there. She had the same issue as you did. Of course, if I have Paint open already, which I much prefer using Paint, it's easy to crop in Paint, right? Do you guys know what I'm talking about? Yeah. Yeah, I'd like to cut out the bottom of that, Oh, crop. Oh, well, there's a crop function right in Microsoft Word. See that? See what I just did there? See, guys? Look up at the board here for a second. See this? Let me try it again. Check this out. Once you've got it there, if you go right-click, and how did I find that? Oh, right up at the top. See that? Crop. Right-click, crop, and then you can just make the picture smaller like we want. And then now I can make my picture bigger, but it's an interesting picture. So you can actually see a little bit. That's fine. Right. Cool. And so if you don't like where the picture ends up, like you can play with different options in Microsoft Word. Like I hit the center icon to put it in the middle. Like I just click on it. Check it out. So if I click on it and then I hit this, it'll left indent it. See that? If I hit this, it'll right indent it. This one would put it in the middle. I don't know where you want to put it, whatever. And of course, you can also be strategic in your moving the graph around in Desmos before you export the picture. If you make the picture in Desmos look like you want before you export the picture, then you don't even have to crop it, right? Just a thought. Doop doo doop doo. Man, I wish I gotta change my default. I really don't like whatever this is.
How do you do the signature?
Upper caret, like, caret. Do you guys know how to change the color in Desmos if you want of the graph? Still stuck on crop the first one? I'm coming. Ah!
Like grayed out for me.
What is going on here? You got, I don't know what you've done here. I don't like it. Let's see here. So let's see here, select all. There may be a better way, but this is the way I'm doing it. I mean, copy. And go back to my, is that it?
No, the other one.
It's fine. Make it smaller. And then right crop. See if you can do the next one. Yeah. For number what? Where are you?
Number 3. And I'm gonna need help because we were never.
Oh, yes, you're getting ahead of me. And could you maybe make that one bigger? I can't quite see what goes on there. Like, try to maybe go back to, for that part E, I think you need to go back to Desmos and do it over
Why?
so we can see what's going on. Like, I can't see.
So what's Desmos gonna do?
Well, you can zoom in. See, go plus there. And then you can, well, yeah. Oh, I mean, you're fine, but you can kind of, do you know how to move? Oh, yeah. I guess you can zoom out just a tad, maybe. That's good. And then export that. But yeah, I'll talk about that in just a minute. You're getting ahead. So by the way, as we're doing number 2, I'd like you guys to just take a second to appreciate what things look like, right? Like, do you notice that we can see you're graphing the function and the inverse function, right? Do you notice that it has that pattern like I talked about Wednesday? Do you see it? Like the, if you look at the graph of the function and the graph of the inverse function, they're related, aren't they? Now, but in order to really appreciate it, I think we need to graph both of them, you know, on kind of a similar scale so we can appreciate the role between the two. But I didn't ask you to plot both of them at the same time, but here it is. So you're to the sine of 1 over x, good. How to make a what? Oh, the inverse one? You just do caret and then -1, like shift caret.
Oh, okay.
Yeah. No, I just did that. You don't have to do what I did. No, I just asked you to graph them one at a time. I wanted to illustrate something, guys. So here I've graphed sine and sine inverse at the same time. This is not part of your lab. This is just me playing around. Do you know how to make the graph of sine just be part of it, not the whole thing? What you can do is you can do curly brackets minus pi over 2 less than x less than pi over 2, close curly bracket. Oh, don't do that to me. Like that. And then what that does is it just graphs sine on the interval minus pi over 2 to pi over 2, right? So like the red graph here is sine, and the blue graph is inverse sine. Do you see how that works? So the same pattern this way, we form that way with the inverse. It's the same exact shape, just run vertically rather than horizontally. That's the way the graph of an inverse function works. I'll probably ask you to do that kind of graphing in a future lab. I'm just showing you now. So, all right, I'm gonna move on to part 3 here pretty soon, because at least a couple people are at part 3. So the way this is going to have to work is like, I'm going to move on. If you missed part, you should come back to it and do it as we have time at the end of lab. All right? Because I don't think we'll have, if we wait for everybody to get done with every part, we're probably going to have trouble finishing labs, generally speaking. And then other people are kind of bored, right? Is that correct? Yeah. Okay, so 3. Let's talk about number 3. I said graph both y equals x squared plus 3x minus 4 and y equals x e to the x. So how do you do that in Desmos? Yeah, so I type in the first one, which was y equals what, x squared? Did I say plus 3x minus 4? I can't remember. Was that right? Three x minus 4, okay. And y equals x e to the x, right? So I said graph both that and y equals x times e to the x. On the same graph, right? So as you see my picture here, I mean, to start with, it looks kind of like this, right? So do you guys understand? If we're solving for x squared plus 3x minus 4 equals to x e to the x, we can think of that graphically as the place where both equations are true, right? So you're looking for where these graphs intersect. And you can kind of see it, right? It's where? It's close to -4, but it's not exactly at -4, I don't think. I'm not sure anyway. Let's zoom in and see what happens. So you can, can zoom in like this. And what accuracy did I ask for? With an error of no more than 0.001. So how far do I have to zoom in to get that? I'm not close enough yet, am I? So now what these divisions are like, how much? 0.02? So still got to go closer in. Now each one of these is 0.01, right? Let's see here. Let's see, how far is this division now? 0.02. So it's 0.01. I think I could figure it out from this graph. Right? What else did I ask us to do? Provide a picture of the graph which supports the solution. So what I'm saying there is you can export the image of your zoomed in picture, right? The what? Yeah, I need to figure out, I need to, let's see here if we can improve our picture any. Okay. So yeah, I think if I export this image, now maybe this one will pay off for us to try to use. You notice the export the graph, you have different features. So as I've made pictures for your notes, I've used different options here. Sometimes I find using like large square gives me like a finer picture, so that might be a good idea here. I'll try that out. And I don't know, I'll put line thickness to medium, see what happens. I really want to open it with paint. Open with paint. There we go. I do not need an extended warranty on my car, thank you. Let's see here. I need to zoom out, yeah. So I think if I can crop this a little bit and still have everything I need, theoretically, right? So, I mean, I need to make sure those numbers stay in the frame. Otherwise, I can't really see what I'm doing, right? And I need numbers, and I need the point of intersection. I think that should suffice if I crop that much. Like, I'm happy with that. Really? Now, once you get the picture here for part 3, the picture alone is not enough, right? You need a sentence that says your conclusion, right? So I want you to write in purple text a sentence which says where the solution to the problem is, right? You would say like something along the lines of, like what I would write is, we can see from the graph that y equals x squared plus 3x minus 4 and y equals x e to the x intersect at the point blah. Therefore, the solution to that equation is such and so forth to within the desired precision. my text is not. Why is I put it on purple. It doesn't stay purple. I don't know. Huh. How do I make my text purple? Oh, maybe it is. I just can't see. Oh, it is. Never mind. The graph above shows the intersection. And it might be good to say which one's red and which one's, I mean, do you know how to do equations in Microsoft Word? You do Alt equals. Do you guys know about this? So the equation editor in Microsoft Word, let me get my marker out here. So this, you do Alt equals. That opens up a little equation editor. Try it out. In Microsoft Word. So it's the intersection of y equals x squared plus 3x minus 4, right? And Alt equals y equals x e to the x. And to improve my sentence here, I should say maybe in parentheses the color of which one. Which one is which one, in my graph, which is the red and which is the blue? Do you guys remember? As we're working on number 3. I think the red is the parabola, and the y equals x e to the x is in mine when it's the blue. At the point. And did you guys figure out what point that is? I haven't. I need to get glasses. Click on it, it just tells you. See, that is exactly what I was hoping you'd tell me. So indeed, that is one of the very nice things about Desmos is we don't just have to use the graph, right? We can go back and click on it and it'll actually tell us the coordinates of that point. See what it is? So we get what? Minus 3.985. Oh, hey, he asked a good question. Would it be better to hover your mouse over it like that and take a screen grab of that? I mean, that would be even better, right? Because then you'd have all the information on your picture. If we wanted to do that, if we wanted to circumvent the yeah, if you, you could also, there's, my way is not the only way here. The question is how can we in our report show that from the Desmos app we've captured the intersection point, right? So his point is even if you're like further out, if you click over that, but does it give you the same precision when you're farther out?
Well, it let me do it, but now when let me put that zoom far in. But when I originally put it in, it had like the.
Yeah, see, it's given, well.
The
Okay. But see, but it's I mean, it also gave you that minus 40, right? Because, I don't know, you got to be careful. You got to be careful you're not deceiving yourself from a more macroscopic view. You know what I mean? Like when we're zoomed in, we're for sure looking at the point of intersection. We might inadvertently, see, because Desmos does 2 different things, right? The one thing it does is it finds intersections of graphs like we just learned, right? But the other thing it does is it finds x-intercepts. And if the intersection of the two graphs is really close to an x-intercept, you could mislead yourself and find the x-intercept versus the intersection of the graphs, which is what we're actually interested in this case. But if I have the mouse like that, if I have that, I wonder if we export a picture, does it put that label in? I don't think it does without. Yeah, it doesn't put it. The Desmos doesn't export that label there without. Now you can. Do you know how to put the label there though? Let's see here if I can. If we wanted to add that label, we could do another thing, which is minus, now I have to remember, not minus 3.985, was it? Comma, what's that? Oh, you're telling me 0. What? Is minus, right? And we can make a label of that. You could do that and say, make the label point of intersection. You could do that. If you did that, then if you do that, oh, and see, I didn't do it quite right. Look at that. See? I didn't put that, the minus 3.985 is not the answer, is it? Curses. I guess maybe I'm too close in. Look at that.
Oh, it's supposed to be 1 instead of 4.
1? This one? 7 what? 741?
No, yes, it's 741.
Like that?
I got negative 3.985 and negative 0.07408.
Hmm. Seems like it's actually it's, well, I think we're running into the graph as being more precise than the answer we want, right? Maybe? Because it's actually not at 3.985. It's actually at like minus 3.98. 4 maybe? Oh, that's not the right way. Negative numbers, right? Oh, that's too far. Anyway, we're within 0.01, which is what I asked for. So, if I zoom out enough, right, it looks like it's spot on, right? So, I don't know. Yeah, let's see here. If you actually want the numbers in that, you just add it to the label. I'll add, x equal to minus 3.985. There you go. If I do like that, then I can export the image and have everything I want on it without. So guys, I'm kind of getting to the weeds here. I mean, there's. All right. So I think I've I think I've said enough about this one, right? Let's go on. Okay. Is everybody clear on if you wanted to solve an equation, you could use graphing to do it with this? It's pretty straightforward, right? Number 4. How are we going to do this one? You might want to start a new blank graph, or you can delete the other ones. I don't know. But just try typing in y equals what? Sine? Did I use an A or a T? Did I have AT? I can't remember if I had AT or AX in that one. I used T this time, right? One of the cool things about Desmos is it's smart enough to figure out when you're using X as your independent variable, or you're using, I spoke too soon. Well, there you go. So what this has done is it's interpreting the x-axis as like the t-axis in this case. So we're looking at time versus y. And this is the graph of y equals sine of at. Now this, I clicked on it. When you type in at, it gives you an option, add slider for a, add slider for t. I just clicked on the big A. Raise your hand if this didn't work for you. See you there? Now, what's especially interesting is if you hit play. Did you try hit and play on the A? See what happens. Where's your? Well, we're going to move on, so you'll have to finish it later, I guess. But you don't have to you could have, well, okay. You can save that as problem, what was that? That was problem curses, little problem. I'm trying to tell them what to save it as. That was problem 3. You might save that other one as problem 3 for yourself, you know. So, so I've asked you here to just, you know, pick a few different, what did I say to make A equal to? 110 and 100. So its default is to go minus 10 to 10, right? How can we fix that? You look at where the slider is, and you click in here somewhere, and you can change it to, say, 1 to, what was it, 100? 110 and 100, or what? 110, 100. So if I do 1 to 100, and this is the step size. If I do step size of 1, it'll work. It'll give me everything I need, like that. You could do that too. I think that would, sure, that's not a bad idea. Just as long as you don't make it 20 so you can't get to 10, you know. I mean, you could make the step size 0.01 if you wanted to, but just, want to see what happens if I do that? Whee! It just takes longer. There's more steps. If you go 0.0, there's 1,000 steps between 0 and 100 if you do 0.1, right? If you just do step sizes of 1, there's 100 steps, right? Goes a little faster. Anyway. But I like your idea of 10. 10 is good. All right, and we don't really care about the animation either, right? Because you stop that.
You have to make it 9 because it starts at 1.
It starts at 9. It starts at 1. I'm just going to make the step size 1 because I'm lazy. And then,
You just want a picture at 110 or 100.
yeah, 1. So, you know, get a picture at 1, get a picture at 10, and get a picture at 100. You know. Now, so here's a question. As you're comparing different cases in mathematics, to be fair to compare to different cases, should you keep the zoom size the same, or should you change it with each case? I mean, it depends on what you want to emphasize, right? If I was to zoom into these graphs, they'd all look the same because they're all sine, right? If I keep the same scale, though, horizontal, you can kind of see how sine of 100t is much more dense, like it's oscillating a lot faster, right? Anyway. All right, so up till now, everything I've shown you is really just kind of introduction to how to use Desmos, right? Like it's not, we haven't really done calculus yet. I've just been showing you some sort of basic graphing options and trying to get you to think about how we can save our work into a Microsoft Word document, right, to document what we did. But the next problem in the lab is actually involving calculus. All right, so problem 5, what I want us to do is to use, I've already set up the calculator for you guys because it's a little bit fussy. So you can click on that link and it should take you to control click, it says. Control click to follow link. It should take you to this one right here. But I'm going to pause for a second. I know you guys are still working on the slider one. Everyone raise your hand when you're done with the slider one for me.
How do you make Chrome your primary internet browser? Because it keeps trying to open it with the Internet Explorer.
When it, you can,
'Cause, like, I'm using Chrome on here. but
Right.
When you open this, it goes to Internet Explorer.
okay, so try to control click. All right, let's see here. Okay, so it's not that. It gave me the option earlier, whatever I did. I mean, it should be under like control panel, right? Let's see, in settings maybe. Well, it would be logical to let me choose it there. So, I guess default apps, web browser. Let's fix that. That should have done it. Oop. Try it now. There we go.
Is my graph reading it correct? I'm confused.
That's fine. Yeah, you need to take a picture of that. And
Okay, no, because I was looking at one, I was like, wait, it's coming from this. I was just making sure I wasn't confused.
all right, so I'll make sure we don't run out of time today. So I'm going to move on here. I think people, if you're not done with the previous problem, it won't be hard to figure it out. So problem 5, there are tables that I want you to fill out using numbers that you find from Desmos. All right? So, so for this one, the answer is just to actually go in and put numbers into here as appropriate, right? But I've shown you how we can use Desmos to calculate those numbers. Let me show you how. So if we open up the difference quotient one, we should get, it should look like this when you get in there, right? Everybody there? Raise your hand once you're there. Got 1, 2. What you doing?
Oh, no, I was still,
You can save that. Oh, you don't have a Desmos account?
no.
Well, you got to do that. Otherwise, you're going to have to redo everything when you get back to it. That's why I made that part number 1. So did yours wouldn't open or would open? You got it open. You got to open. Is it taking you to Explorer so it won't work, or is yours? You had a control click because Microsoft Word is. Why is it taking the whole thing? There we go. All right. All right, he's setting his account up. You got it. So obviously I have a different, so let me just talk about this one for a second while he's setting his account up, all right? So what do I have in here? I have f of x equals to x squared plus 2x plus 3. So let me just go ahead and take a second here and work out the difference quotient for that one. We have f of x equal to x squared plus 3x, 2x plus 3, right? So if I calculate the limit as h goes to 0 of f of what, let's say a plus h. Well, let's see here. I have a equal to what? 1. So let me put in 1 here for a second. Minus f of 1 divided by h. What do I get? So we get 1 plus h squared plus 2 times 1 plus h plus 3 minus, yeah, well, just hold on a second here. What is f of 1? 1 plus 2 plus 3, which is 6? 6. So we do that algebra. That gives me a 1 plus 2h plus h squared plus 2 plus 2h plus 3 minus 6. So you do the algebra, and I have 1 plus 2 plus 3 minus 6. The numbers cancel. And I have a 2h plus 2h. I get 4h, 4h plus 2h. Wait a minute, do I have... I haven't messed up. 2h. Yeah, so I have 4h. Yeah, that's right. So I have 4h plus h squared over h. So I can cancel this and this and that. And what do I get? I get 4. So if I work out the algebra of the difference quotient here using limit laws, I get 4, right? Now, what I've done here is I've added what I'm looking at is I put my function up top, right? Here's the difference quotient, f of a plus h minus f of a, divided by h, right? And I added sliders for both h and for a. And what I did was I set up the slider so that it's pretty zoomed in, right? Like I set the slider so it goes between minus 0.1 and 0.1 in steps of 0.01. I think that will allow us to get to the values that I've asked you for in the table, right? But check out what happens here. And I'm going to leave that a at 1 for the purpose of this problem. But so let me make this line a different color for just for a second. Do you know how to make a different color? Well, here it is. I'll make it green. No, you shouldn't try to do it. You have to click on the link in the lab write-up. I don't want you to try to do it here. I'll come help you in a second. But so my point, guys, is that if we look at the h equal to what I have in the table, minus 0.06, 0, and so forth. So if I put it on 0, what happens? What does it tell me? Undefined, which is good because you can't divide by 0, right? So one of the things in the table is easy, undefined, when we plug in h equals 0. Now if I plug in h equal to what? 0.02? This one gives me what? Well, this one gives me a difference of 0.402. Now you go to minus 0.0. I bet you went to minus. Oh, yeah. If we go to minus 0.02, it's 3.98, right? And so we can move the slider for h and find the values of the difference quotient for all the h nearby and fill out the table. I want you to appreciate, like numerically, they're all going to be close to what we could, of course, derive using the limit laws approach, right? So what you need to do is you need to take this f of x and you need to replace it with the one that's in the problem, which was what? Like square root of... So square root of x. If you do SQRT, it should bring up like a square root. So, sorry.
Yeah, no, I'm just making sure because it comes with default.
That would be ideal, yeah.
Because it keeps opening.
Sure. There you go. And now you can just go there and put square root of x plus 8 to get started. Well, I mean, if you do SQRT, it'll come up. Or you could use the keyboard like you pointed out, yeah.
Yeah, I use
Type in the full thing, or do you want to like go to the 100, the 1,000?
Oh, let's, just maybe what? I think 2 digits should probably, 2 decimal points should probably suffice for our purposes here.
You want to round it or leave it like it is?
Rounded would probably be wise. So that would be 0.07, I guess, for this one. 0.17, rather. I can't read. You can either use this keyboard down here. You're fine. Like that. Or you can go SQRT and it'll come up. Either way. So in future labs, I am not going to talk the whole time. I'm just going to give you the lab and let you work at it, all right? And I'll help you individually as you get stuck on problems, okay? I think that's what I'm going to try for like the future lab formats, hopefully. Actually, I say that, but I'm not entirely sure that that's the right way to do it either. I don't know. No, there's no pictures to copy here. You just need to find the number and put it into the table. 2 decimals should work. They're all 0.17. Well, 2 decimals won't work then. How many decimals do we need to take to get it to be interesting?
I'd say
At least 4? Yeah, I guess I got to figure that out here. Yeah, I think we'll probably, you need to take 6 decimal places to make it interesting for that one, isn't it? Fair enough. The first 3 decimals are just fixed for the whole thing, aren't they? There's only what's that? I think we need at least, well, I mean, 4 is something, but 5 would be better. If you've already done 4, that's fine. You can move on.
yeah,
Is good?
yeah, I'm good.
Okay, just checking. I guess the smart way to work here would be to downsize the Desmos window so you can have the Microsoft